The ratio test is often used when factorial is involved. N factorial is defined to be the product of all of the integers from n to 1. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 0 factorial is defined to be 1. Also, n plus 1 factorial is n plus 1 times n all the way to 1. But the product from n all the way to 1 is n factorial, so n plus 1 factorial can be rewritten as n plus 1 times n factorial. For example, determines the convergence of the series to n quantity factorial divided by n factorial divided by n factorial. We're going to use the ratio test with a sub n being 2n factorial over n factorial times n factorial. And so a sub n plus 1 is 2n plus 1, the whole quantity factorial, divided by, we replace n with n plus 1, and we replace n with n plus 1. The limit of the ratio a sub n plus 1 over a sub n is the limits of a sub n plus 1 times the reciprocal of a sub n. But 2n plus 2 factorial can be rewritten as 2n plus 2 times 2n plus 1 times 2n factorial. And n plus 1 factorial can be rewritten as n plus 1 times n factorial. We then canceled out n factorial, 2n factorial. What we have left is the limits of 2n plus 2 times 2n plus 1 over n plus 1 times n plus 1. This limit is 4, which is greater than 1. So by the ratio test, this series is divergent.